All right, so this is a pending video that haven't been able to do because of time of doing other things. But now that we have these two units, which are the wireless servo drivers, we're going to write the code to control this unit and have access to the NRF24. Once we have that class ready, we'll transfer it to this one to control it here and send data to this ones. But in order to test this one, we need to have a receiving unit. We don't have it yet. So we're going to use the Pico, which we already have. This one can send and receive data to the NRF24. So we'll use this one for testing purposes, and then to debug it, the data we get here is going to be sent to the phone, and we'll be able to see it. So we'll be able to send data from here to this to the phone, and then this to test the other way around, we'll have this one send data to this guy's here, and this one will control a servo. So that will be our way of seeing the output. Okay. So you put this away. Let me switch my view. I'm going to be doing the project from scratch. So if you're following along, this is going to be a long video. So first we start a new project. I'm using STM32Cube IDE. This is because the processor I'm using, it's an STM32. So I pressed Alt-Shift-N for new project. We'll select STM32 new project. Okay, this is the part that takes a while because it needs to download all the configuration files. Almost done. Okay, should be coming up any second. There it is. Let's search for our processor. STM32G070KB. Next, give it a project name, wireless servo driver. It will be a C++ project, just like all the other ones. And the configuration, if we look at the schematic I shared on the previous video for this unit, we have pin 7 through 9 are going to be LEDs, LED R, Y, G, and then 12 through 16 are interface for the NRF, and 18 is the PWM for the servo, so we'll leave that one for last. So let's make the changes here, the pin changes to the device. So I'll set them as output. These are for the LEDs, so we'll set those first. And I'll give them a label. LED red. Oh, that's the wrong one. I want this one here. LED R. LED Y. And LED green. Okay, next we'll set the SPI. So actually, let's set the clock. We want the clock to be at maximum speed. This processor can handle 64 megahertz. So we'll set it to 64 megahertz. That way we can drive the SPI at maximum speed. So the SPI for the NRF can handle 8 megabit serial interface, and it's an 8-bit command set. So we'll make those changes to the SPI. So let's go select SPI, enable it to full duplex. We'll go to parameter settings, change the bit to 8 bits since it can handle 8. And right now it's running at 32 megabits. We need to lower it to 8. So that's 8 megabits. That's really fast. We also need to set the the GPIOs or the pins, we need to drive them low for the SPI portion of it. So we'll select each one of them, drive them low. If you don't, it'll start acting randomly power up. At least I've found that with those type of processors. Uh, we also need these two outputs, one for CSN and one for CE. So let's go to GPIO and give it a label too. So CSN, uppercase, CSN, and CE. And the last one is the PWM. So it's a timer. It's timer 1 on channel 1. And we'll go to timer 1. Enable channel 1, this one here. And we'll enable PWM on channel 1. The servo controller requires a 20 millisecond cycle. So we want to set the prescale to 64. So divided by 64, it will give us a million. And then we'll set the cycle to be at 20 milliseconds. Okay, so that's all we need to do. We can save it and generate the code. So that should be all the device configuration. Now it's just going to be adding code. Now this project is a C++ project, so we need to set a structure for C++. So we click on project new source folder on the project, not on project new. And we'll call it CPP. And this is where the C++ files are going to be housed. So folder 1 for includes, new folder for source. We'll create our first source file, which is the main source file, and we'll call it main.cpp. And inside here, we'll include main.h. This will be our main loop, and we'll return 0. So now that we have this, we need to have a way of calling this from C. This is C++, so to call it, to jump from C to C++, what you do is you go to this file, main.h, add the header, the function prototype, somewhere in the file. This is fine. And then now you can call it from within the C file. And we're going to call it just before the loop. So we need all of this to initialize before we call it. So there it is. Let me compile, make sure I'm not missing anything. I'm sure I'm missing some stuff. Okay, not yet. The other thing we need to do before we get going is we need to put a reference to this one as an include. Otherwise, when we start creating classes, it's not going to find it. So we'll right-click on the project, go to properties. And since we're on settings, might as well go to miscellaneous and add the capabilities for floating point, for printing or outputting floating point. We might not use it though. We'll go to general under C++, paths and symbols. Under C++ includes, we're going to add the new folder. Check all of those boxes and navigate to the folder include. Click OK, OK, apply and close. We're good. We shouldn't need the main anymore, and we should not need this one either. We should not need that one anymore. So let's add the class to handle NRF. So this will be a class, NRF24L01. We'll create two files, one for the header file. We'll add it to include, and the source file to source. And here we'll include main, just so we have access to the C code. And just like every class I do, we need private vars, public vars, and public functions. Okay. First one we need we need a pointer to the SPI port. So SPI should be a handle, and it's a pointer. We'll just call it port since this is SPI. Then we need pointers to the CSN port and the CE port and just pin numbers. So GPIO type definition, and this will give us the CSN port. GPIO type definition. This should give us a CE port, or that's where we're going to store the CE port. We'll keep them as pointers. Yeah, let's do pointers. Okay. Then we want integers, 16 bits for CSN, and another one for CE. A couple of helper variables. So we'll have one 16 bytes or 16 bits. We'll call it size, and we'll define it as 1, and 132 bits. We'll call it timeout, and we'll say 1000. Okay. Let's say 2000. So we don't have to modify it. Now, functions, we don't know what public variables we're going to use yet, so we'll jump straight to functions. We need to overload the initializer because this one's going to take the SPI handle. So port, and then the GPIO type definition for the CSN port, and the same for the CE port. This is CSN, and this should be CE. We want to read registers since communication with devices is all about accessing the registers and reading and writing. So we'll read. It needs to return something, so it will be an integer read register. Okay, and it will be a single. We'll just give it a register, and it will give us data back. We also need to write, write register. And we need to tell it what to write. So it will be data. One more. This will be for multi write. Come on, do it. Data, and the we want the how many bytes we're writing. So size of data. Right? Yeah. Okay, since this has multiple functions, we'll do a few at a time. So let's do this ones first. Copy that. Go to save it and go to the definition file. The functions have to be prefixed with the class. So let's add that to them. Okay. Here we can assign our local variables to what we're getting as parameters. So CSN port and CE port. This should be CSN. Okay. We need to set the pins. This one to low, high, and this one to low. And since we're going to be switching back and forth a lot, we're going to add helper functions here. So we'll call it CSN low, GPIO write, GPIO write. Okay, we'll say CSN port to the CSN, and the pin state GPIO pin low will be reset. Okay. We need one for high, and should be set. We need a couple for CE. Okay, we're good. And we don't want to forget this at the end. It looks like I had one and I pressed enter, so it gave us that. So let's remove it. Let's go back to doing this. So CE low and CSN high. Okay, that's the initialization code. Now reading a register, for reading a register, it requires it requires this bit to bit 0, and we can only write those bits that are A. So we can safely write a register as 0, and then read the data. So we'll say int a register, and we'll set it as 0. Okay. And then, since we're only reading one register at a time, let's see. Actually, we don't even need to set the register. I guess what we could do here, we can just reassign the register and say, which one? The last 5. So 1, 2, 3, 1, 2, 3, 4, 5. So only those are allowed to change. So we'll take the register, filter it through these bits, make sure that only those can go through. And then we can write, but SPI transmit, we can transmit the register, size 1 timeout, same. And now we can read the result. So uint result set it to 0, and then SPI receive, and they'll port the result, size, and timeout. Before we can do this, we have to specify CN as low because it's active low. So that means that if it's high, it's no one has access to the bus. And then CSN high to reset it, and we want to return the result. Okay, that should be good for reading data. So this one is a pass-through, so we just send it to the next function below, and we'll send the register and the data 1, since this one is supposed to be for 1 byte. This is multi-byte. Okay, and this one here, this one, what happened? Let me go to the end. Okay, so for this one here, writing a register is this here. So this one, we do need to set a bit number 5 to 1, and then filter it through those, use that mask. So we'll reassign register, and register will be that, and that, and filter it. So now what we do is we set 1 to 0, and we set the A's to 1. That's 5 of them. 1, 2, 3, 4, 5. And here we leave the 1, and we set the A's to 0. 1, 2, 3, 4, 5. Okay. So now, okay, so we're getting data in 2 parts. We're getting a register and data. So we can do 2 writes, one for the register and then another one for all the data, but we're just going to do 1. We'll create a local buffer and it will be the size of data plus 1, and we'll assign the register. Then we use memcopy to copy into the buffer, move the pointer 1, and then add the data and use size of data. Okay. Then we can say CSN low SPI transmit, and we'll use that one, set the buffer. The size will be size of data, and the timeout, we'll leave the timeout as is. Hopefully the 2 seconds is enough. We do need to increase this one by 1 because we created the buffer 1 byte bigger than what we're getting. Okay, and then we say CSN high, and that should be it for that one. Let me compile, make sure there's no errors. And obviously we have errors. That would be because this one requires a library. We don't know, it doesn't know where it's coming from. So let's go to the header and let's include it here. That would be the stdio. Actually, no, it should be string. Let's compile again. Same thing. Oh, this one here. What now? All right. It doesn't like it this way. Other platforms, it doesn't care if you put an equal sign or not. And oh, that's not it. Hold on. What was I? Why did I do that? I put it back the way it was. I like it like that better. Where is this? This one here. Let's compile again. All right, no errors. We're good to go. Let's add more stuff to it. We're getting close to finishing this thing. Where are we? The header file. So now that we have this, we want to enable config. We want to be able to switch modes between transmitting and receiving. RX is receiving. We want to send messages, right? We want to receive messages. One too many? Yeah. Message. And we want to check if we have a, just an integer. If we have a new message. 8. New message. Okay. So we'll add these functions. And I believe that's pretty much all we need. And then we should be able to send data and receive data to the Raspberry Pi. So we'll go to the bottom here, prefix all of those functions with the class. Okay. The configuration. Let's go look at this. So if we look at the flow of the datasheet of the NRF, it says that at power up, we need to give it a delay of 11 milliseconds or 10.3 milliseconds. And then once we do that, it'll be at the state of power down. So if we want to go to standby, and from here we can go to sending or receiving, we set this to power up and wait 1.2 milliseconds. So let's go look at that one, the power up. And that should be on the configuration, register 0 right here. And we're going to be taking as many defaults as we possibly can to make it quicker. So this is the power up. That's bit number 1, 0, 1, and then we'll keep that default on number 3. So first, let's set CE to low, just in case, resetting everything, CSN to high, and now the delay of 11 milliseconds. And now we can write the configuration. So it will be register 0, 1, 2, 3, 4, 1, 2, 3, 4. And it says this is the power up. Oh, come on. What happened? This is the power up, and this is the CRC, right? So that's 4 and 4. This is config. Next one will be disabling the auto acknowledge. That's number 1, register 1. But before we do that, there's a delay here of let's do 1 millisecond. I know it says 1 point something, but we'll do 1. Should be fine. So we'll write register 1, and we'll write it to 0, so it disables the acknowledge channel. So the channel on the Raspberry Pi is 60, so we'll set this one to 60 so they can communicate. So it's a 5, yeah, register 5, 60, okay, and we're gonna access this register 7 for status down in other functions down the line. So we'll do A0 or 0A for the receiving address, 10 for the transmitting address, and then we'll change this bit to signal that we're sending 32-byte messages. So 0A, the name on the Raspberry Pi is called Gyro-C. So we'll do the same for 10. And with set for 11 will be 32 bytes. So that's the configuration. Now the mode for texting or for transmitting, not texting, transmitting. So we're here. This way is transmitting, this way is receiving. So we'll go transmitting here. And it says we need to have data in the FIFO. We need to set this bit to 0 and then pulse this one to 1 for 10 microseconds, which means that we have to have this one at all times as 0 and this one as 0. And we should be in text mode or transmission mode. So we want to read the register first because we only want to change 1 bit. We don't want to screw up the configuration. So let's call it config, and we'll read a register. The register is configuration 0. Then config will clear the bit. I can type. So that's the first bit, bit number 0, that will clear it. Then we can say write register, and we'll write the register 0 again and pass config, right? And it also says that when you switch from here to that, there's 130 millisecond settling time for both receiving and transmitting. So when we switch modes, we'll do a delay of just 1 millisecond. That should be enough. CE has to be low. Okay. For the receiving should be similar, but not the same. So for this one requires this bit, with the one we just cleared here, to be 1 and CE to be high. So we'll switch this, so it sets it to 1, and this one will be high, and that should be enough for that configuration. Oh, I changed the wrong one. All right, so it should be here. Okay, and this should be high. Now for sending data, so we need to load data on the FIFO before we we do this, right? So this is already set to 0, this is set to low, so we need to load data, pulse it, and the data should go, provided the bit is set to 0 and CE is low before it goes high. So to write data to be sent, it requires this to do a payload. So we'll copy this and we'll specify a variable. So we'll call it reg and we'll say we'll load it there. Because we want to send everything in a single message. Actually, we don't even need to have these variables. We do need a local buffer, and this will be, the messages will always be 32 bytes in this example. So we'll make it 33 so we can append the message to this buffer. So we'll do memcopy, we'll put the buffer, we'll increase the pointer by 1, so it starts at 31, I mean as at 1, and then it'll leave that register, this data there, intact. And then we'll put message 32 bytes, okay? Then we can say CSN low, we can call the SPI for transmit, we'll send the buffer, and the size will be 33 bytes. And the timeout, let's leave it the way it is. Should be fine. And CSN high. Now we need to pulse CE. So CE high and a delay. Let's put 1. And CE low to keep it in transmit. If we leave it high, then we're gonna start receiving if this bit changes. And when you send data, there's some interrupts that fire, so we want to clear those, because if you don't, then you stop, you're not able to send data until you go back and clear them. So it's register 17, hex 17, and the no, I'm sorry, it's a status register, so 7, this one here. So for transmitting, we have bit 4, which is if it sends a message, doesn't receive it, it will try again until it maxes out. If it maxes out, it sets the flag, which means that until you go clear it, you can't send anymore. And then this one as well. So 4 and 5 will clear. So we'll write a register and its status. So it's 7, 2, 3, 4, 1, 2, 3, 4. So it's 4 and 5. So this is 4 and 5. There. Okay. To receive a message is somewhat similar, but not the same. So we'll copy and paste that part. Silent space there. And that's different, that command. So let's go to commands again. So this is for receiving. Let's copy this. And we'll copy this. So that's for receiving. And this one, we do have to send it in 2 parts. One, write it and then read it. Because to write a command, you have to write a command. And to receive, you have to receive. So you transmit and receive. So we don't need the buffer because we can't use it. But we do need a place to hold this, so we'll call it reg. Okay. And I just noticed we're missing something here, right here, that one. Okay. And we'll transmit the register 1 byte, which is size, right, what we defined before, and then SPI receive for receiving the actual message. So is the port, the message goes here, and the size will be 32. That's the size of our messages. The rest stays the same. We don't need this. We do not. And the bit we need to clear now is for receiving, not for sending. So we'll go to status register number 7, and now it's for text or transmitting is bit number 5. So it will be this one and clear this too. That would be enough. The last thing we need is the FIFO status. Should be, I think it was 17 here. So we want to check to see whenever we have a message, because we're not using interrupts. So whenever we have a message, this flag is set to 1. Or not whenever we have a message, but whenever we have something in the pipe. So if there's data in the pipe, this will be set to 0. If it's empty, according to this, if it's 1, then it's empty. If it's 0, then we have something. So we'll read 17. And we'll say, actually, we don't even have to do all of this. Like we can just say return, read, register 17. What happened here? 17, right? And we compare it with 1, 2, 3, 4, 1, 2, 3, 1. So that's the one we want. And then we'll reverse it. So if it's a 1, it will send us false or a 0. And if it's a 0, it will send us a 1. So let me compile, make sure everything works. There's no errors. There's always errors, obviously. What's the error here? All right, so it doesn't like it because it's expecting an integer and we're passing a character. So let's convert it. 8 and pointer. Jesus. All right, let's compile again. No errors. So now we should be able to test. So if we go to main and include NRF, and we'll need access to the SPI port. And because it's in C, we need to tell it that it is in C, and we should have access to it. So it will be an SPI handle, and all the ports are the same. They all start with H, and then the name and the actual number. So this is SPI 1. All right, so NRF, and then we'll do NRF, and this one. So we'll get the port, CSN port, and CE. Why does it do that? CE port, CSN pin, and CE pin. Okay. Very important. You want to call config, right? And then we set the mode. So to test it, we're going to send data to the Raspberry Pi. So we need to set the mode to transmit, mode TX, and we'll declare a counter just to test. So uint, wow, I can't. All right, so counter equals 0. We also need a message. So the message will be 32 bytes, and it's not going to have anything right now. We'll use sprintf to load something into message. So we'll say from not from servo, but from STM, and we'll add the counter here, and here we'll say counter plus plus, and we send the message. Message. We'll add a delay of just every half a second. We'll send the message. Let's compile. It's probably some errors. Yeah, it doesn't know what sprint is. That's because we need to include something here. The IO library. Compile again. Okay, we're good. So let me load it into the unit. So let me switch this. And we'll connect one of them. Okay, let's go to the code, download it. Need to click OK here. So it's downloading. Okay. Now let's connect this thing. We need to make some code changes to the Raspberry Pi. And oh, this is not going to be enough room. So let me remove this thing right here. Move my phone right here. Let me load my application. And let's see, is it going to connect? So there it is. It's sending. It's not sending that data. It's sending from the previous video I did earlier. So let's change that code to receive messages from NRF. So this is the code, and here we already have the NRF enabled. We need to specify that we'll be receiving data. Let's disable these two lines so we don't send data to the phone. And since we're not going to be sending data, we'll disable these ones as well. And I believe that's all we need because we have code already checking to see when we send a message. So when we get a message through the NRF, it's going to pass it through directly to the Bluetooth unit connected to the phone. So then we'll see that message on the phone. Let me compile this. Make sure nothing's broken. Okay, no errors. So let me reset my unit, switch my view, and drop the file into the Raspberry Pi Pico. And you can see we're getting those messages, right? STM. So now if we go back to this, let me enable this part, and we change this to NRF and just a number. And let's download it. And as soon as it downloads, we should see the message change to NRF. So there's the NRF and the counter. Obviously, it's going once every half a second, even though it looks a lot slower here. That's how fast it's running. So now that we can receive data, now let's send data to this unit here through the Pico. So we'll switch that code again, and this time we're going to switch this one to transmitting, and we'll re-enable this code. So this one just takes the role of the gyroscope and sends it over, and it should catch it. So we should be able to catch it on this green unit, and we should be good to go. So let me compile this part. Yep. So let me switch the view again. Reset this. Disable this so we can see it. Drop the code into the Pi, and we should see different data here. It'll just start flying really quick, or not. That's because we forgot to enable something else. So that the other two lines, these two lines we disable. So let me do that again. Compile. Let me hide that again. Reset it. And now we have all the data from this little guy here. So now let's go test this one. So now that we have the phone, and we can see from the phone that come on, go away, that everything works. We'll get a servo right here. Let me move this to the other side. Right there. Okay. Move this here. This one requires 12 volts for this unit. So let me connect 12 volts to it. We bring it around here, move this out of the way, move this out of the way, and then connect ground, power. Okay, there it is. Let's give it power. Let's connect this. Right? It doesn't do anything right now, but that's what we're going to change. So, so now we can go back to the code here and switch to this one. We'll change this to receive, right? But in order to do the servo, we need PWM, so we need to enable that part, and we have not. So we need to say, we need to enable the timer, PWM, what is it? Start. All right, so the channel, we need access to the channel, obviously, so we'll put a 1 there. Since the channel, that's what it is. And this one should be a PWM, no, what is it? Channel 1. I had to look at my codes because I don't remember channel 1. Okay, so we need to give it access, so it should be a handle as well. And they're all the same, right? It's the H and then what it is, and then the port, and we're using channel 1. And we're gonna initialize it using a macro. So this one is called HAL times set compare. Okay, we give it the handle, which would be that. The channel, come on, 1. And we'll start at 1500 since the servo needs to run between 500 milliseconds and 2 milliseconds. So that would be half, 2.5 milliseconds, sorry. And now that we're receiving data, we can add code here. And actually, we can just copy that code from this one here since it should be the same, right? That one. So we don't need this part anymore. We'll comment that out. We'll add that there. Formatting is way off. Doesn't matter. So if NRF message equals 1, then receive the message. And instead of doing this, and instead of doing that, we need one more variable here. And we'll just call it a double. And this will be angle. We need another one to call it degrees per tick, and this will be the 2000 milliseconds it needs to move back and forth, divided by the servo type, which is 180 degrees. And then we can use this time compare again, bring it over down here, do the conversion. It will be from a string to an integer, and we are changing the message, and it will be angle. Okay, I think that's correct. And here we'll just say plus. It will be the angle times the degrees per tick. I think that's correct. Hopefully. Let me compile. Let's see if it works. I don't think we have anything for this one yet. Yeah, we don't. I don't know where it is. I think it's under this one. Let's see. Nope. Where would that be? too many arguments. That's a different one. Okay. And then this one, temp channel R, 1 and 1. Compile again. Now, where are the errors now? There you go. So we have 13 errors. Wow, that's a lot of errors. Oh, that's usually because something else is not right here. So let me comment this out. Let me make sure that those aren't the only ones giving me errors. Yeah. Let's go to the definition of that one. Okay. I know what it is. The handle. Okay, so same with this one. Compile, we're good. Let me download it. So if we did everything, this thing is gonna start moving when I move this. Oops, I didn't switch the view. So now that it's working, very cool, right? So that means that now that we have that code, we can put it here, and this, when we move it, it should do the same function as this. So let me disconnect this from power, so there's no power on this one. We'll set it aside. We'll open the project for this one, move the NRF files to it. So let me switch my view again. We'll open this project, and we'll copy this file. So we'll copy this one to include, and then we'll copy this one. Oh, did it move? Oh, I moved it. That's not what I wanted. Let me copy back. Yes, copy the file. And let me copy this one up. Yes, copy the file. So now here, I can go with this main. This is a different project. So let's close this one so there's no confusion. Close this project. You shouldn't need it for now. And we'll include the NRF now that we have it. And we can just come back to this code here, the one for the Raspberry Pi, and it should be pretty similar, if not identical. So actually not that part. So we'll just have to write it right here. So we'll say NRF, and we require a handle to that one. So it's SPI handle. What happened here? Oh, we need to change the configuration as well. This is a long video. Come on, open, open. Did I not click it? I guess I didn't. All right, so we need to enable the SPI on this one. We also need to set the SU pins for CSN and CE. So let's name those two before we enable SPI. So as for PV0, this one here. This one is CSN, PV1, CE. We're going to SPI, enable SPI. We know that these pins have to be pulled to ground, all three of them. And then the parameters will be set to 8 bits and the prescaler to 8 bits. And if the clock is set correctly, it should give us 8, which we did. That's all we need. We can save it. And now we should have a handle here for SPI. There it is. So HSPI1 and NRF will be the HSPI1. No, it's not going to give me the functions. That's okay. It's CSN, the port, CE, the port, and then CSN, the pin, and CE, the pin. Now it's not giving me the declaration of the definition of the header, so we might get an error. We'll see. Let me compile, make sure there's no errors. Looks like we do have. No, we don't. All right, we're good to go. So now that we have that, we'll disable this part. Actually, we'll leave this part the way it is. Now we'll disable it. And we'll just send the role. So log I, we'll send H, actually R for role. And it will be 2 decimal, and R. So we'll see the role on the phone updating, and then in message, now we can take this here from this one here, and we'll use this right there, and we can send it, send message. Okay. Anyways, can I format like this? No, I cannot. I don't know how to format here, so I'm just gonna leave it the way it is. So if I compile, it's just gonna loop, and it's gonna be sending data to this unit here, to the green one. So let's compile and download. And while it does that, let me switch the view. Oh, wait, I can't. Oh, I sent it to the wrong one. I sent it to this one. Now I don't have the. Hold on, let me switch back again. Let me enable this. I reopened this project so I can resend this code. So let me close this so there's no confusion, right? What I'm sending. So that way I can download it. I can download this project here. That's not what I wanted. I want to open a file. So I can send this to this one here, and it'll have the what it had before. So let me download it. I pressed download without having this one connected, so it overrode the other one. Okay, so we're good. Let me disconnect it. This one has power from the 12-volt power supply, and then I'll connect this one. Right? Let me download the data of the other project. So we'll close this one. And if we did everything correctly, we should be able to open this one. And let's open a file just in case. And we'll send it to this one. So let me hide this. So when it finished loading, if it worked, this should start moving, right? And we should start getting data here as well. So download it, but nothing's happening. Oh, this one has a different connection. So nothing's happening with this one. So we'll check that one, but let's check this one first on the phone. So this is a different name. Let me connect to it. Settings, HMSoft. Say dismissed. So we're getting data, but the data is invalid. Right? For some reason, we're not reading the gyro. So, and I don't know why, because we are getting the data. And oh, that's because we're not sending it. So gyro roll, we're not sending it here. We are sending it here. I don't know why this one's not working. Probably because this one needs to be a float like that. Okay, so let's download it again. Again, coding without letting you see. So I didn't have this here, this gyro roll. That means that it wasn't sending that part. And let me move this here so you can see it once I start getting data here. So you can see the 50 there, right? So Well, I'll do in a minute. And then this one was set to D instead of that to F. So let me hide that part again. And now we're getting that data there. So if I move this, you can see the oh, this one, sorry, that's the wrong one. Right, that's the roll. However, this one's not getting it. Why not? Well, that would be because where's the NRF? So here, let me switch it back again. That is because when we configure the NRF, well, the NRF needs to be configured. We didn't call that part. And also, we need to switch the mode to transmit. And let's load it. When it loads, we should see these things as I move it, not do anything. What happened? All right, let's see. So I have the NRF, the port, CSM port, CE port, and everything. Configure the text mode. For some reason, it's not working. Um, let me see. Let me check this. Make sure this is correct. Okay. We have the, oh, okay. So the problem here is that the clock is on the wrong pin. We're connected to this one. So we have to move it. And I'll just select the clock right here. And, oh, sorry, that's I square CSSPI clock. And it removed it from here. Now it's there. So I'll save it. Oversights. I will download it now. Let me hide this part so you can see this. So now, as I'm moving this, if everything works this time, it'll just start moving this thing. There we go. Right? So now we have the whole thing. So we have this one with valid code that also sends to the phone, just like the Pi or the Pico. And we have this one receiving data as well from this. Okay, so that's all I have. I'll upload the file so you can download. That completes this project for the Gyrocam. How you set up your servo is up to you. But now with one unit, you can control as many as you want. You know, put them wherever you want. And then you can add code to configure it from your phone if you like, because it has the HM11 on it. All right, enjoy. Oh, before I go, one last time. I don't know if I said this at the beginning of the video, but in this project for the Pi, I mean for the Pico, if you go to this file, this one should be a 1, not size of data. So I made a typo there. I made a mistake, not a typo, it was a mistake. It should be size of data, or you may get weird data when you write calibration. So make sure it's 1 on line 93 of the BNO. Okay, later.